Okay, we go on. All right. Okay, can you see the slide, scientific method?
Yes.
Yes, Prof.
Okay. What we want to do will be to go through these slides. This slide, the scientific method, is actually for, I think, primary school student. It's a K12 or K12 student. But introducing scientific methods, which I found it to be useful for very simple basic introduction to scientific method that is applicable at all level, including you in PhD, masters and PhD level. So we go through that. But I'm going to refer back to these slides later, even throughout semesters. I'm going to mention these slides again. Right. There are 6 steps to the scientific methods. And they are problem. You start with the problem, question. You find the information about the research. You have hypothesis, data collection, observation, and conclusion. Now let's see each one of them. By following these steps in order, you will learn about your problem. Notice in the order, the in order part, it is very important. Again, being systematic, scientific method being systematic, it must be in order. Okay, in Islam, the Muslims remember tertib. When you do your prayers, when you do your ablution, wudu, it must be tertib. You cannot wash your hands or before you wash your face, for example. So that's same thing in research. We cannot start by collecting data before you identify the problem. So the problem or questions is the unknown that you are trying to solve or the questions you are trying to answer. So remember, as I said earlier, or we have been talking from the beginning or from last week, that research always start with a problem, and the problem is the unknown. Okay, the question. There are some questions that is unanswered. That's why we do research. If there is no questions, then we don't do research. If we cannot develop a research questions, then there is no research that need to be done. Yeah. So so try to narrow it down and be specific. The question is always narrow. Like we see the example earlier, we talk about plastics, floating plastic. Floating plastic is a problem, yes, but the study that you are studying is not really about the floating plastics as such. The plastic pollution is too big. Yeah, everybody is doing it. So specifically, you just want to know how the plastic behave in water. Okay, the hydrodynamics. Yeah? And same thing like the corrosion, big corrosion. So this is only about ion transfer. The previous example that we see, it's only about ion transfer, whether the ion transfer to make it melt. So that's it must be narrow and specific. And then you collect information. Has someone tackled this problem before? Gather information about the question, the problem, books, magazines, experts, okay, past experience. This is for student, for school student. That's why they did not mention anything about journal, yeah. And then you have hypothesis. Hypothesis is an educated guess about the relationship between independent and dependent variables. So when you do research, you must know what is meant by independent and independent variable and dependent variables. So anybody wants to say what is meant by dependent variable and independent variable? what is independent variable and what is independent variable?
Both is chain here.
Yep. Can
Can I try?
yeah.
Independent variable is this the result we try to achieve. Example, increase of corrosion resistance. Then the dependent variables
Mm-hmm.
are those factors that can change the corrosion resistance if we change anything of the variables.
Mm-hmm.
This is my
Okay.
understanding.
So okay, for example, if I talk about engine performance, maybe easier. You want to see the effect of changing air fuel ratio on engine performance efficiency. Okay. Uh, which one is the independent variable? Which one is dependent variable? Between
What was the example again?
air fuel ratio, and engine performance.
I try. Prof.
Yep.
Hanif
Go
here.
ahead.
So
Yes.
the independent variable is the fuel ratio where we can change it, and the dependent variables is the efficiency of the engine efficiency. So because it will depend on the fuel ratio itself.
So the efficiency is
Is the dependent
efficient
variable. Yeah.
dependent variable.
Yes.
Anybody wants to say something else which is different from what Hanif said? So we see that the independent one are the one that we change. We control to change, that's independent. The dependent variables are what happened, okay, the effect of what we change. So in this case, the performance or the efficiency is the dependent one. It depends on what the fuel ratio that we have set. Okay, so that is independent variable, yeah. So this is hypothesis, okay. If independent become this, then then the dependent become. If the air fuel ratio become this, then the performance efficiency become that. Okay. So this is an explanation about dependent and independent variable. The manipulated and the independent is the manipulated or the thing that we change. The dependent will be the response. So data collection, of course, you do data collection through experiment, field survey, simulation, and so on. Okay. And if you do experiment, you must have control group. Okay, that serves as standard of comparison. And the control group may be a no treatment or experimental selected group. And the control group is exposed at the same condition as the experimental group, except for the variable being tested. We are going to see an example after this. And based on the example, I think we are going to understand better after this. So we have control group. And then the constants, we need to keep certain parts constant, certain variables, certain parameters. And then we do the observation analysis, collect information, and then you may plot graph charts and so on. And from there, you analyze. And finally, you can conclude whether what you expect to happen or not. So whether your hypothesis is correct or not. Okay, I think we better after this that we look at the example. And then you report your findings. The end of research is the research is not considered as complete unless you have reported, which is publish your results. If you have not published it, then you have not done your research completely. So now we see an example. Okay, this example is something that you, as I said, is in fact this whole file is taken from the internet. I've given the link in the front page. This example is available almost. There are many versions of it available on the internet, and you just search for John and grandmother baked bread. Then you can find this many slides and people talking about this example, because this is a realistic example that can make us better understand what we mean by scientific method. And I'm going to mention John's work in the future. I'm going to refer back to these slides. Okay, now there is this boy named John. He watches his grandmother bake bread. He asks her what makes the bread rise. She explained that yeast releases a gas as it feeds on sugar. John wonders if the amount of sugar used in the recipe will affect the size of the bread loaf. So he is curious to know. So research is always about curiosity, wanting to know whether the amount of sugar used in the recipe will affect the size of bread. John researches the area of baking and fermentation, tries to come up with a way to test his question. So that is a question that is the unknown that she is looking. So he has the research problem. Research problem is nobody has done the research or study about the effect of amount of sugar on the bread size. So he looks into that, and he come to a certain hypothesis. If more sugar is added, then the bread will rise higher. That is his hypothesis. He thinks that if you have more sugar, the more sugar you add, the higher the bread will rise. You have the more bread volume. So what are the variables in his study? The independent variables?
The amount of sugar.
Okay. Yeah, the amount of sugar. In this case, he's going to use 25 gram, 50 gram, 100 gram, etc. Up to 500 gram in his experiment. And what are the dependent variable?
The size of the loaf.
The size of the bread or the bread loaf, yeah? Okay, which is the size of the bread loaf. So because his grandmother always uses 50 gram of sugar, John will use that as the control group. So he knows that 50 gram, that's what the grandmother always use. So let's use 50 gram, and then he's going to change from 50 gram further up. So what are the constants? Anybody want to suggest the constants?
The temperature, maybe.
The number of yeast,
The time.
type of yeast,
Temperature, type of yeast. What else?
Time.
type of flour, maybe.
Time for the leaving the bread in the oven. The type of oven, type of flour, brand.
The method.
So even the utensils used here, all the same. So other ingredients, the brand of the ingredients, rise time, air temperature, humidity, type of pan use, oven use. cooking time. So all this will be considered a constant. Okay. The only thing that changed is only sugar, the amount of sugar. So he did the experiment. And he records all this his data in a table, and this is his observation. So by looking at this table, what is your conclusion? Anybody?
Can I try?
No, can we hear somebody that has not spoken before?
Okay, okay.
Okay, Abu Bakar, yes, very long way. What time is it, Abu Bakar, there?
I'm not feeling fine. That's why today I even joined late.
Okay, okay.
Hello.
So,
Yeah.
what do you want to say something about this? What do you think is what is your conclusion or your comment on these results? Is that Lei talking? I don't quite hear properly. Okay. Anybody else?
Hi, Prof.
Yeah. Who?
I'm Chua. Chua.
Chua. Okay, yes, Chua.
From the observation and from the result that the increase of amount of sugar is not affect the size of the bread, and oppositely, when increase the amount of sugar, the size will become smaller compared to the control group. The amount of sugar is equal to 50 grams. So this is the conclusion
Mhm.
that I have seen from the
Yeah.
data. Thank you.
Okay. Thank you, Chua. Afiq? Is Afiq around? Afiq?
Uh,
Afiq?
hello, bro.
Afiq
Hello,
is not
bro.
around, eh? Absent. Yeah, who, Abu Bakar? You want to say something?
Like what I observe is that
Yes.
uh,
Hello,
the based
Abu
on the
Bakar,
analysis,
continue. Yes.
based on the analysis, it observed the size of the bread loaves. He observed on different size ranging from different grams that means from smaller to the larger gram. And the correlation is that, though it's a little bit confused on me, he used different gram of the bread and to carry out his trial based on the grams. So his conclusion was that he found out it's a little bit confused to me. If you notice the correlation between the bread, either by test, um,
Should
yeah,
Okay.
yeah.
All right. Okay, Abu Bakar. Um,
Yes.
Fred, is Fred around? Fred?
Pardon?
Is Fred around? Nope. What about Hafizah? Hafizah, you have anything to say?
Hello?
Yeah.
Hello?
Yeah, hello. Go on.
My observation is the size of the loft increasing until it reached the control group. But then is
Okay.
if the grandma added more sugar, the size of the loaf decreases. So the experiments of the John not achieved
What do you mean not achieve?
because John wanted to do experiment if he increased the amount of sugar, the size of the bread.
Those who are not speaking, please switch off your mute your microphone. Yeah. I've not. Hafizah has not copied what she wants to say. Yep. So okay. Hafiz Adnan is around. No. Hafiz Adnan. Zulhelmi. People not responding. Hello. Can you hear me?
Yes, Prof.
Yes,
Yes,
yes.
Prof.
Yeah. Because I
Yes,
don't hear
yes, yes.
anybody speaking, so I'm a bit worried.
We are
So
cracking our brains.
Hafiz Adnan, are you here? No. Zulhelmi, Nurul Aina, Nuris, and Muhammad Mustafa. I've not heard anything from you. From of you, anybody want to speak? Okay, the question is, what should we do? What should John do with these results? Or what should be, just close the book and that's it. Finish, go home. I mean, he needs to do something else. Anybody wants to say anything?
Right?
Yep. Who?
Amirul.
Amirul. Yeah.
The increased size of sugar lead to a bigger size of bread up till 50 gram only, which is the optimum volume of sugar. By then, afterwards, it will deteriorate in size.
So,
Meaning it will increase until the optimum level of sugar only. After that, it will decrease.
yeah, what should John do then? Basically, close book, that's it.
He should small the sample size, probably between 0 to 75 or something, just to see until which exactly it will become deteriorate actually, or which it will become increase. I mean, to extend the level below the 100, but not exceed 100, just to see the limit of the optimum, actual optimum level of sugar.
Mm-hmm. Okay, that could be a possibility. Anybody else want to suggest anything that John should do?
Try.
Yeah.
As we can observe, the control group, the amount of sugar is 50. So the closest is 100. So maybe he maintain 100 amount of sugar.
Mm-hmm. So maintain 100.
Yeah.
But you 100 you get 1,116 only. Why not? Let's say grandma is already correct. It's 50.
Mm.
So
I'm referring to the control group. It was 50.
uh-huh.
And the closest is 100 when we observe the average size.
So
So
what is his advice to grandma? Just keep the 50 or go to 100? Or do you want to do something else?
I'm not sure.
Mio,
Prof, I
Mio?
suggest to increase maybe at least every 5 gram or 10 gram up until 75 gram for the test.
Okay. So that means you suggest a retest.
Yeah.
Huh? Just like Adero just now, up to 75.
Yeah. To have
Okay.
optimum results.
Maybe the optimum is at 90. You don't think so?
Uh, I don't think so. Maybe.
Why? How do we know where do you think is the peak?
I think Prof Hanif here.
Yeah, Hanif.
I think John should put the maximum of 100 is a maximum value for the sugar, and then he can check back the optimum between 50 to 100. So it may
Okay.
be high, yes.
Okay. So you think the peak lies between 50 to 100?
Yes, because
Correct?
from 25 to 50 is still increasing, but in
Yeah. Okay.
between 50 and 100 is decrease. So there's optimum there.
Okay. Is Noris here? Noris? No, still Raya. Zahelmi. Nur Aina. Tahmid. And Muhammad Mustafa. You have not spoken? Okay. We go on, Right. So, okay. Actually, you can only determine what happened if you plot a graph. The table does not explain very much, but you plot graph, then only you know. How do you know? What do you know from here? That the peak is, the graph could be like that, right? So that's why it is important for you to always plot your graph while doing your experiment. Like this, imagine if John has completed his experiment. Okay, I've got finished my experiment. Okay, keep all the everything in the oven, wash all the utensils and everything. And okay, I'll go and do my analysis later. But he found that when he plot, then he got this one. Then he has to redo the experiment because the peak is somewhere in between 50 to 100. Yeah, there. So yes, he examined the data, notices if you examine your data during the experiment, then you are able to redo your experiment, add on and so on during the experiment. Otherwise, you may have to come back to the lab to do experiment and so on. Then it makes life difficult for everybody. So John rejects the hypothesis but decides to retest the sugar amounts between 50 gram and 100 gram. And this is his results between 50 to 90. Okay, so he used 10 gram only the difference from the control group, and this is his new plot. Okay, the new plot, and the peak is at 70. And if you plot the graph, you know that it is already 70, not 75 or 65. Okay, so 70 is already good, and that's the result. So, conclusion, 70 gram produces the largest loaf. He accepts his new hypothesis. Finish. Okay. So, any comments on this experiment by John? As I said, I'm going to refer back to this his experiment later many times throughout this semester. So please remember, when I say John's grandma's bread experiment, this is what I'm referring to, because it has something to do with your PhD work as well. Okay, any comments? Otherwise, I intend to stop the class now.